Okay, we're going to be looking at the quotient rule here. The quotient rule definitely requires some memorization, and we will prove it today. So you're going to be looking at a function where you're taking the first function and you're going to be dividing it by another function. Okay, and in order to take the derivative of this function, you're going to take the first the function on the denominator, and then you're going to multiply by the numerator. And then you're going to subtract the numerator, and you're going to multiply by the derivative of the denominator. Okay, and then that's all over the denominator squared. Okay, so that's quite something to memorize. There is a little trick that you can use to memorize it. A little song you can kind of sing to yourself is you take the low, which is the denominator, times the low d high, you say, low d high, minus high, which is the numerator, times d low, all over low squared. So that may help you. Okay, so let's get into a proof of why this is what it is. Okay, so to prove it, we're going to take the derivative of u divided by v. And we know that that's going to be equal to the limit as h approaches 0 of f at x, x plus h minus f at x over h. Okay, and just to double check, our function is f of x equals u over v. Okay, so when I do that, I'm going to end up with the limit as h approaches 0 of and I'm going to plug u in, so it's going to be u of x plus h divided by v of x plus h minus u of x over v of x all over h. Okay, so in the next step, we're going to basically get a common denominator. So I'm going to go limit as h approaches 0 of v of x plus h times v of x. So that's going to give me u of x plus h in the numerator. So it's going to be u of x plus h times v of x minus, okay, the v of x is all set, so I'm going to add v of x plus h times u of x. Okay. Now, this step right here, we're actually going to get to the point where we did it in the last proof, where I'm just going to add and subtract something that's exactly the same into the function. So I'm going to take the limit as h approaches 0. I'm going to take u of x plus h times v of x. I'm going to subtract v of x times u of x. And because I just subtracted, I'm also going to add it. V of x times u of x, okay? And then I'm going to subtract this up here. So I've got v of x plus h times u of x. And this is still all over, and I lost over h here. This is all over v of x plus h times v of x. Now, since it's 1 over h, I can just make this function be times 1 over h. So the h is just going to come here, because if I multiply, if I have an h in the denominator of this fraction, I can multiply, and it would be 1 over h over here, so I'm just going to bump it into that value. Okay, so just to remind you, what I just did is this expression right here is just 0. So I just added and subtracted the same expression, so nothing really changed. Okay, so now I'm going to try to clean this up a little bit. These two values right here, I can take a v of x out of both of those. So I'm going to get the limit as h approaches 0. I'm going to take v of x out of this. V of x times u of x plus h is left over minus u of x. Now I'm just going to be really selective. I'm just going to take this over h. I'm still going to leave the rest of this all alone. So it's still going to stay over x plus h over v of x. I'm just being very picky about what I want, very well knowing that this is going to be a derivative of u and I need an h in the denominator for it. Okay, now I'm going to go over here and I'm going to subtract Now I'm going to take these two values and I'm going to pull a u of x out of both of these. Now I've got to be careful with the signs on this one because this sign is negative. So if I take this one first, okay, if I take taking negative u of x, then I'm going to take this right here. So if I take a negative u of x, I'm going to be left with v of x plus h. Now this is positive, and I have a subtraction here, so I need to subtract this value, v of x. Okay, so I've taken a u of x out of both of them, put the u of x out. I took this value first, so v of x plus h, and then subtracting a negative results in a positive v of x times u of x. And I'm also going to take the h for this expression. Okay, so now we got to clean it up. So now I've got the limit as h approaches 0. Okay, so what I've got here is v of x. What I've got here is the derivative of u of x. So I'm just going to say this is the derivative of u of x. Okay, what I have here is u of x, and what I have here is the derivative of v of x. Okay, and now this is going to stay all over this numerator of v of x plus h times v of x. Okay, so the numerator is in good shape. I have the derivative of the bottom times the derivative of the top minus the top times the derivative of the bottom. This still needs to be cleaned up, so let's do a little substitution. Let h be 0. So now I have v times the derivative of u minus u times the derivative of v with respect to x. Now if I substitute in here, that's going to give me v of x, and v of x times v of x is v squared. Very nice. We have just proven the quotient formula. Okay, so now what I'd like to do is to pick a problem that involves the quotient formula. So let's do an example. All right, so we're going to pick a relatively complicated example to start with. So I'm going to say, okay, I've got x plus 1 times x plus 2 over x minus 1 times x minus 2. All right, so this could be really tricky because this is a product rule. So I'd have to use the product rule twice and then use the quotient rule. Now that's a little silly and a little extra work. So instead, before I start using the product rule twice, I'm just going to multiply this out. So that gives me x squared plus 1x plus 2x gives me plus 3x plus 2. And then the denominator gives me x squared minus 1x minus 3x. Minus 1 times minus 1 is plus 2. Now, I could have used a product rule. I would have gotten the same answer when I get all said and done. But it's much easier to just multiply these out first. All right. So this is going to be considered to be my top function. This is going to be considered to be my bottom function. Let's just review what the derivative is going to be. It's going to be take the bottom times the derivative of u minus u times the derivative of v over v squared. Okay, so I'm going to take the first function, which on the bottom is x squared minus 3x plus 2, and then I need to take the derivative of the top. The derivative of the top is going to be 2x plus 3. Okay, then I'm going to subtract the top, which is going to be x squared plus 3x plus 2, times the derivative of the bottom, which is going to be 2x minus 3. And that's all going to be over x squared minus 3x plus 2 squared. Okay, this problem, sometimes it's tricky as to where to actually stop when you're solving a problem like this one. Okay, and I'll show you some of the things that tend to happen. Usually you don't have to multiply out the denominator, but this expression shouldn't be left messy like this. You should clean that up. The denominator doesn't need to be cleaned up. So we're going to leave the denominator as is. We're not going to multiply this out, but we are certainly going to clean up the numerator. All right, so when I FOIL out here, double distributive property I should say, I'm going to get 2x to the third minus 6x squared plus 4x plus 3x to the second minus 9x plus 6. Subtract. Okay, Now when I do this, I'm going to end up with 2x to the third plus 6x to the second plus 4x, subtract 3x to the second, subtract 9x, subtract 6. Okay, so when I go to clean this up, I'm going to end up with a lot of things canceling. So let's see, 2x cubed is going to cancel with 2x cubed. Negative 6x squared and negative 6x squared is not going to cancel. Plus 4x and minus 4x is going to cancel. Plus 3x squared plus 3x squared is not going to cancel. Negative 9x plus 9x is going to cancel. 6 minus negative 6 is not going to cancel. So I've got a couple x squared terms here. So I've got, let's see, negative 6 plus 3 is negative 3. So that's negative 3x squared, and then I have negative 6x squared, and all right, so that I believe is negative 6x squared when it's all said and done, because I had negative 6 plus 3 is negative 3, and then I have negative 6x squared is going to be negative 9, plus 3x squared is going to be negative 6. So yes, I'm going to get negative 6x squared, and then I have plus 6 minus negative 6, which results in plus 12, over x squared minus 3x plus 2 squared. So that is your derivative using the quotient rule.